I will explain in this video a quick recap on how to implement the SLAM algorithm and gmapping on your robot. So first, let me clean this window. Okay, let's see first on Visual Studio Code where are the main files and how do we configure it. It's pretty simple. Okay, the first thing that we must have is this folder, or any folder that you want to put your SLAM algorithm. Next, let's see the main node, or I mean the main launch file. Just ignore that. That's not pretty necessary. Those are my flags for enable sensors or disable laser and so on. The three things here is that you first try to launch the robot description and also the robot publisher. But I launch it when I launch a gazebo, so I will not explain that here. Next, you need to launch the file of your SLAM algorithm, in this case gmapping. So we will pass it and we'll review it later. And finally, you launch rviz with the model that you want to visualize, and also all those parameters that are necessary to view the sensors. Next, we will feed in on the gmapping algorithm node, and it's pretty simple. It gets an Lua configuration that is here on the gmapping on the config folder of the SLAM algorithm, and those are the default parameters basically. So I didn't change anything. Just to know that there is a YAML file about gmapping. Next, we need to specify the arguments of gmapping. Also, we need to call the node. Obviously, we have to style gmapping with the command rus noetic gmapping SLAM. Let me see if I could see in gazebo. Sign up. I mean in synaptic. Sorry, it's late today. Gmapping. So here is you have to install rus-noetic gmapping, your rus-noetic SLAM gmapping, your rus-noetic open SLAM gmapping. When you install that, you get access to this gmapping node and can launch the node with the parameters. So that's all. Are only three files for launch the gmapping algorithm. As you know, we will implement another SLAM algorithms like Carto, Hector. So that's why I got this argument, because all the files will be jetbot underscore Carto, jetbot underscore Hector, and so on. So this was the first test to see the algorithm work. And let's launch it. I will only launch it because I have a separate video on how to use it. So first, we launch the gazebo node, or the gazebo simulation. Rus launch jetbot gazebo spawn launch, spawn jetbot not launch. And finally, we launch the SLAM simulation of the jetbot. This rus launch jetbot.slam, jetbot underscore slam, jetbot underscore slam dot launch. So here is my there's a Turtlebot3 work with the jetbot here. and we can start navigating with the keyboard or with the RQT controller. On the other video, I put the keyboard to navigate. It's pretty hard, so I will try to launch the RQT controller. And with the RQT controller, it's more simple because we can make a little bit of okay, here we have. Oops. So as you see, the algorithm start to fill the gaps using the gmapping algorithm. So when you finish to, I will stop here. So when you finish to map your environment, the next thing to do is to save the map. So for example, let's say we want to get the map here. So the next thing, you try to launch maps and must run map server map saver. There's a function to save the map, -f, and the name of the map, let's say Jetbot, and that's all. Enter, and the map is saved. If we see, there is a map named Jetbot. So I think we can open it with MeshLab. We'll try to open MeshLab. Let's find the map. Okay, here is a home Jetbot workspace source Jetbot drive navigation maps. Oops. I'm sorry. Let's try to open it with in hand, or try to pull it directly. Jetbot workspace source. Jetbot disk drive. Navigation maps. Jetbot. Okay, there is no with the image viewer. So here is the partial map. I have another maps of this Turtlebot world, but as you see, you can get a view of the generated map at any time if you want it. This is the final map on a separate video. It's a complete map of the Jetbot world, and that's all. You then when you finish to map your environment and save, then you can use this map to do autonomous navigation like I did on the previous video. So that's all. I hope you understand how to implement the SLAM algorithm. It is a quick, easy, but it's a lot of complicated probabilistics. So hopefully someone develop those things for us to just use it and make it better robots. So thanks, see you next time.